Welcome to the deep dive. You're here because, well, you want to get up to speed on big, complex stuff fast.
And thoroughly.
Exactly. And today we're tackling geoengineering.
Hmm.
These intentional, really large-scale ideas for tinkering with the Earth's climate system to fight climate change.
Yeah, it's a huge topic, and we want this to be your shortcut to really understanding it.
We've been digging into a great StarTalk discussion, actually. Neil deGrasse Tyson was on it, Gary. And Danielle Visioni, she's a professor at Cornell, really knows her stuff on stratospheric aerosols and climate intervention.
Right, she specializes in that. So we've pulled out the core science from their chat. We're aiming to give you a really clear picture based on what they discussed.
Okay, and we'll mostly focus on the two big categories, right?
Right.
Reflecting sunlight away.
Solar radiation management, yeah. And the other one is pulling greenhouse gases out of the air.
Greenhouse gas removal. Got it.
And, to really get this, we need to touch on radiative forcing. That's basically the balance sheet for the planet's energy, what comes in versus what gets trapped.
Okay, let's unpack geoengineering itself first. The key thing, as they stressed on StarTalk, is that it's intentional. Humans deliberately trying to alter the global climate.
For beneficial outcomes, supposedly. That's the goal.
It's proactive, not just like building seawalls. It's trying to modify the whole system.
Exactly. And those two main strategies you mentioned, managing the sunlight coming in
Solar radiation management.
and taking out the greenhouse gases already there.
Greenhouse gas removal.
Right. And the StarTalk chat also mentioned, this isn't a totally brand new idea out of nowhere. People have thought about this before.
Oh, like who?
Well, they mentioned Edward Teller, the physicist. He was apparently an early voice suggesting we should at least study these kinds of climate intervention concepts.
Huh. Okay, but before humans even thought about it, nature's been running its own experiments, hasn't it?
Oh, absolutely. That's a key point they made. Volcanic eruptions.
Right. Big ones.
Huge ones. They're like real-world tests showing how stuff thrown into the atmosphere can seriously change the climate globally.
Like Tambora.
1815.
Exactly. Tambora was massive. So much ash and gas went up that it caused the years out of summer in 1816.
A year without a summer.
Yeah.
Wow.
Yeah, crops failed, weird weather everywhere. It just shows how sensitive things are to what's in the atmosphere.
A really stark example. And the StarTalk folks also talked about a more recent one, Pinatubo.
Pinatubo, yeah, 1991 in the Philippines. That eruption pumped a lot of material into the stratosphere and caused a noticeable global cooling for maybe 2 or 3 years.
Measurable cooling.
Definitely. And it actually made the atmosphere less transparent. Astronomers apparently had trouble observing things clearly for a bit.
That's wild.
And it's funny, they mentioned Benjamin Franklin way back, noticing that really hazy cold weather seemed to follow a big eruption in Iceland, so people have suspected this link for ages.
Okay, so volcanoes cool things down. What's the actual connection to these geoengineering ideas? It's the aerosols, isn't it?
It is. It's all about aerosols, these tiny, tiny particles floating in the air.
Like dust or soot. Yeah, or in the case of volcanoes, mainly sulfate aerosols. They come from the sulfur dioxide gas the volcano releases.
And these aerosols, they reflect sunlight.
Exactly. Especially the really small ones, the submicron particles. They're just the right size to scatter visible light really effectively. So less sunlight reaches the ground and things cool off. Like billions of tiny, tiny mirrors, as they put it on StarTalk.
Okay, tiny mirrors reflecting sunlight. Makes sense. But hang on, why do the volcanic aerosols have this big, lasting global effect, but, like, our everyday pollution factories, cars, which also makes aerosols, doesn't seem to cool the whole planet in the same way?
Ah, that's a really crucial difference. It's all about where the aerosols end up. Altitude is key.
Okay.
Volcanoes, especially big ones like Pinatubo, shoot material way, way up into the stratosphere. That's the layer above the troposphere where our weather happens.
Right, above the clouds and rain.
Exactly. And the stratosphere is incredibly dry.
Yeah.
So there's no rain to wash these aerosol particles out. That washing out process is called wet deposition.
So they just stay up there.
For a long time. Months, even a couple of years. Plus, the stratosphere is, well, stratolite. It's layered and very stable. There isn't much vertical mixing, unlike the turbulent troposphere below. So the particles don't easily fall back down.
Okay, so they get stuck high up, dry, stable, reflecting sunlight for ages.
Precisely. Whereas the pollution we make down near the ground in the troposphere, it gets caught up in weather systems and rained out pretty quickly, usually within days or weeks.
Wet deposition gets it fast.
Right. So the implication for geoengineering is pretty big. The science suggests you wouldn't need to put a huge mass of aerosols up there compared to, say, volcanic eruptions. Injecting a relatively small amount into the stratosphere could potentially have a significant cooling effect.
Because they last so much longer up there.
Exactly. Much more efficient in theory than trying to achieve the same cooling effect with particles released near the ground.
You know, what really struck me from the StarTalk discussion was that our current pollution is already doing some cooling, unintentionally.
Yeah, that's a huge point. Human activity, especially burning fossil fuels that release sulfur dioxide, creates sulfate aerosols, mainly in the lower atmosphere. And these are reflecting some sunlight.
How much did they say?
They threw out a number like maybe 100 million tons of these human-caused aerosols go into the atmosphere each year. And that's masking some of the warming we'd otherwise see from greenhouse gases.
So we're already accidentally geoengineering, kind of.
In a way, yes. An uncontrolled, messy, unhealthy way. But yes, there's a cooling effect from that pollution.
And this leads to that weird paradox, right? When we clean up the air.
Exactly. As we put in cleaner air regulations, especially in North America and Europe, to reduce sulfate pollution, which is great for health, stops acid rain, all that.
Good things.
Absolutely essential things. But the side effect is we've reduced that cooling aerosol haze. So some of the warming that was being hidden or masked by the pollution is now being revealed.
We unmask the warming. Wow. So cleaner air, ironically, lets the greenhouse effect show its true colors more clearly.
That seems to be part of the picture, yes. It's complex.
Definitely complex. Now, they mentioned some science terms, too. Me-scattering.
Right, me-scattering. That's just the physics term describing how light interacts with the particles when the particles are roughly the same size as the wavelength of the light. It explains why those submicron aerosols are so good at scattering sunlight.
Okay. And wet deposition, we covered rain washing stuff out.
Yep. And the sulfate aerosol formation itself. Volcanoes blast out sulfur dioxide, SO Euro. That gas reacts chemically in the atmosphere, gets oxidized, reacts with water, and eventually forms tiny droplets or particles of sulfuric acid, HSOU.
Sulfuric acid. So acid rain is related?
It can be, yeah. Those particles eventually do come down, and if the concentration is high, it contributes to acid rain. That's one of the potential side effects of deliberately injecting sulfates, too.
Okay, so we've got the science, the volcanic parallel, but the StarTalk discussion didn't just stop there. They got into the really tricky parts, the implications of actually doing this on purpose.
Oh, absolutely. That was a huge part of their conversation. The biggest caveat, maybe, is that spraying aerosols into the stratosphere, the solar radiation management, it's just masking the symptom.
The symptom being warming?
Right. It cools the planet, potentially, but it does absolutely nothing about the root cause of the high levels of TORO and other greenhouse gases in the atmosphere. Those gases are still there, still trapping heat, still causing ocean acidification.
So the StarTalk folks called it a Band-Aid.
Yeah, a potentially risky Band-Aid was the vibe.
Yeah.
Because you're not fixing the underlying problem. You're just counteracting one of its effects, temporarily.
And that risky part, what did they focus on there?
Well, a whole host of things. Ethical issues, societal impacts, environmental side effects we might not fully understand. Like, what happens to rainfall patterns if you start reflecting sunlight globally? Could it cause drought somewhere else?
Unintended consequences.
Big time. And then there's the who decides question. Who gets to control the planetary thermostat? What if one country starts doing it and it messes things up for another country?
Yeah, you can see geopolitical conflict brewing right there. The StarTalk discussion brought that up, right? The potential for tension.
Definitely. If geoengineering deployment isn't globally agreed upon and managed, which seems incredibly difficult, you could easily have winners and losers and major international disputes.
And what about the long term? If we actually started doing this, relying on it, but didn't cut emissions?
That's maybe the scariest part they discussed. Imagine we deploy aerosols for decades, keeping temperatures down while Kuro keeps rising. Then something happens, war, economic collapse, a technical failure, and the aerosol deployment stops abruptly.
No.
All that mask warming would suddenly hit us very, very fast. It's called the termination shock or termination problem. You could get decades worth of warming compressed into just a few years.
Catastrophic.
Potentially, yes.
Yes.
It really highlights that this can't be seen as a substitute for cutting emissions. At best, some argue it might be a temporary measure to buy time, but it's fraught with risk.
Okay, so let's try and wrap this deep dive up, drawing from that StarTalk discussion. Geoengineering. It's humans deliberately trying to tweak the climate on a massive scale.
Right. And a major focus right now is solar radiation management, specifically mimicking volcanoes by putting reflective aerosols way up in the stratosphere,
Mimicking Tambora and Pinatubo, basically.
using the lessons learned from them. The idea is it could cool the planet relatively quickly.
And this is a huge, but it's treating the symptom, the high temperature, not the disease, which is the greenhouse gas buildup.
Exactly. It's that Band-Aid analogy again. And it comes with significant unknowns, potential side effects, massive governance challenges.
And that terrifying termination shock risk if it's stopped suddenly without the underlying problem being solved.
Which really underscores what the StarTalk experts were getting at. These potential interventions, while maybe worth researching carefully, can't distract from the main job of cutting greenhouse gas emissions.
So here's something for you, the listener, to think about. Given that geoengineering seems like, at best, a temporary measure, maybe even a risky one, how much focus should it get compared to the fundamental task of cutting our emissions drastically? Where should our priorities lie as we explore these powerful but potentially double-edged technologies?
A tough balance.
It really is. We hope this deep dive gave you the context you need to think about it more clearly. Thanks for joining us.